For this problem, it starts off sounding kind of simple, find the area of R, but if you decide, or if you are determined that you're going to do things the normal way and have your rectangles be vertical with tiny little dx's, you have to realize, number one, that the top of the rectangle changes at this x coordinate, and that would mean you would have to set up two integrals. Number two, once you do set up those integrals, you're going to see natural log sitting in there, which you do not know how to integrate that function, at least not until second semester calculus. So you are out of luck going this direction. That means you need to make a dy integral. Now, if you draw horizontal lines in the region, you can see that the right side of those horizontal lines will follow this line. You can see that the left side will follow the curve that is here, and they have a point of intersection. Now, don't assume that it might be 1 for the y value of intersection. You need to actually put this in your calculator, check that intersection point, but be careful, you need the y intersection point. The y coordinate of intersection is 1 point, let me write that down, 1.30656. And you are going to be integrating from y equals 0 to y equals that number. So what I'm going to do is I'm just going to say that for this intersection point, the y coordinate and then I named it capital B. B is not used anywhere in here, and I'll just put a B up here and then continue on. I know that I need to find this horizontal length. That means I need the right x coordinate and the left x coordinate. That means I have to take both of my equations and isolate x in terms of y. So for the logarithm, you want to remember that the natural log is base e. So if I e to the power both sides of the equation, that is the inverse function of the natural log. Those will cancel out, and you will have that your x is equal to e to the y power. For the line, add the x over, subtract the y over. So the right x coordinate is the line, 5 minus y, minus the left x coordinate is e to the y. Now you have to still solve this integral. You were told to find the area of R. Now, this is allowed a calculator. So you can throw this in your calculator and get a nice answer out of it. And that will give you 2.985, or it will round up to a 6, either or. Okay, letter B. I'm going to erase. And I should probably keep those x values that I found. So let me write x equals e to the y, x equals 5 minus y. Very important functions. Now, region R is the base of a solid. For each solid, cross sections perpendicular to the x-axis is a square. Perpendicular to the x-axis is the first thing I look for cross-sectional volume. Is it perpendicular to x or perpendicular to y? that means that I have a nice long length of a side of a square that is a vertical length on the xy plane. That leaves me with only a tiny horizontal cut. This is a dx integral. Then I look at what is the area formula of the cross section. Because it's a square, it's length of side squared. The dx integral goes from x equals 1 to x equals 5. And you can double check by looking at where the line crosses the x-axis. However, you might notice that right here it does go through a change. So they're going to force you to deal with it in this way. Now, kindly, it is a write but do not evaluate, an expression involving one or more integrals that gives the volume of the solid. So I actually want to, in this case, not take these versions. Oh, I already wrote that. So I've got all this set up, but I've got a problem. I have to go to the x-coordinate of this intersection point. So if I call this intersection point A comma B, we had already found B. For the previous problem, A is equal to 3.69344. So I will integrate from 1 to A, and then I will have to add to that an entire another cross-sectional volume perpendicular to the x-axis, going from that x-coordinate A to x-coordinate 5. The area formula is again a square, and the length of the side is a vertical distance. So for the integral where I am working with x equals 1 to A, the top y is natural log x. The bottom y is 0. I don't have to write minus 0. I will for the emphasis, you do not need to. Then, as I travel from x equals A to x equals 5, this time the top y is y equals 5 minus x, and the bottom y is 0. Again, I do not have to write that minus 0. Now, I want to point out, double check this. You have a dx integral. You are only using the x variable, and it is the x limits. Dx, only x variable, x limits. And then I want to point out that in the previous integral, it was a dy. You should have only y variable in the integrand, and these should be y values where it exists. Always double check, especially when dy comes out. So that was setting up the expression. Next, the horizontal line y equals k divides R into two regions of equal area. I'm going to erase all of this so that I can draw in here nicely. All right, now, horizontal line y equals k divides R into two regions. So if it is dividing R into two regions of equal area, it has to be somewhere between 0 and the y coordinate of intersection. Let's just call it about there. equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. Now, you have a couple of options here. You already found the area of R in part A. So if you want, you can say that, well, let me write down, in part A, we had gotten 2.98, either 5 or 6. That number divided by 2 must be equal to the integral. And then it's easiest if I let the rectangles go horizontally. From x equals 0 to sorry, I should clarify first. You have a right x coordinate and a left x coordinate. And when you have a horizontal length, it is a dy integral because those are tiny y cuts. So that means that the limits on my integral are y values. Y equals 0 until we reach whatever k is equal to. Then I need the right x minus the left x. So that goes back to the formulas we had found earlier. X equals 5 minus y creates the right side. And x equals e to the y makes the left side. I didn't need the parentheses, but I wanted to emphasize the subtraction. And that would work. You could do that, or you could have done the same exact integral with 2.985 divided by 2 and say it was k to the y coordinate of intersection, which was 1.30656, or you could have just said b of 5 minus y minus e to the y. Or you could have said the integral from 0 to k is equal to the integral from k to the y coordinate of intersection, and then the area being the 5 minus y minus e to the y. Any of those three are correct, and that is it.